Hi all. In this video, we see a paper titled Monte Carlo Tree Search for Simulated Car Racing. So this paper is about MCTS Monte Carlo Tree Search applied to simulated car racing in a talks environment where it requires to utilize an efficient forward model and discretization of the action space. The action space here is pedaling, braking, and the steering, which will be coming into the later part of this video. So, what is Monte Carlo tree search? It's a search method that builds a search tree iteratively, utilizing simulated playouts using a forward model that we commented earlier. So, this is a particular version of the MCTS called Upper Confident Bound on Trees, which was formulated in 2006, which will again give a brief description about what is UCBT. What the ability of the MCTS is, if we have to do a search space in an exhaustively a big one, which is a very computationally expensive or inability to do and find an optimal solutions, what it does is it tries to build tree iteratively and to make educated guesses. And while doing repeated iterations and many training, these educated guesses become an optimal solutions. And this has done a breakthrough in different turn-based games such as Go and Hex. And it's also applied to real-time games like Super Mario, StarCraft, and Pac-Man. And there has also been some kind of a modifications done to the core part of the MCTS algorithm, tailored to the particular necessity. So in this particular simulator car racing, the interest is because there are many challenges which posed by simulator car racing for differently formulated AI methods. So here the AI method we are trying to formulate is based on MCTS. It's very challenging and also very interesting to apply this MCTS for the car racing. And the reason is it has many fold. One is it has a continuous action space. We know that MCTS is mainly applied for the discretization action space, and it also has to be limited by a real-time decision making. It has only few milliseconds decision has to be taken, and also that kind of necessity to do some foresight while doing a car racing. We needed to have some foresight what would be happening in the near future to avoid collisions and also to follow the track as quickly as possible. So, and the author says, as far as the AVAR is concerned, this is the first MCT has been applied for the self-driving vehicles, and it has, and particularly they have used a particular platform called Talks, where a different kind of AI method has been utilized to understand their methodology in car racing competitions, and this competition has been held annually under the IEEE auspices. There are different types of algorithms has been tried out for car racings. Most of them are based on ANN, artificial neural networks, and evolutionary algorithms, and some of them are handcrafted, uh, human-oriented fuzzy logic. So related work is there are some kind not very big related to MCTs, but there are some algorithms has been generated based on genetic, particularly to identify the best line or best path along the track, so that we can accelerate as much as possible. So some of the models are basically on the sensor based, but for a simulated thing, we need a track model, which we will try to build based on the sensor data, which we will be again explaining in the third sections. So here is come the real explanatory part, that how that MCTS is and how it is been tailored for the simulator car racing. So MCTS, as said earlier, it's a tree search algorithm in which the search space is it's been probed by some stochastic sampling. So because as earlier, the search space is computationally inexpensive to find the optimal solution. So we do an iteratively build a tree to direct to the optimal point which is termed to be as a node. So they do a stochastic sampling through the forward model, and through that forward model there are different nodes are formed, and every node is given certain weightage based on its optimality using the evaluation functions. So at every iteration what it does is it has some four steps. uh, as here so it's a policy where the which node has to be selected, and that nodes have been expanded paying a simulator playout, and that once that different nodes are being visited, and the nodes are given a particular value by doing a back propagations. So for this going along propagating along the different nodes or building a different tree branches, we need an efficient forward model, and also we needed to have some an efficient evaluation functions to give some values to the nodes, so that in future once the tree is built, we can search along the nodes which has a highest values. So it is an anytime algorithm that doesn't require that I need us to go for this many iterations only, then that can be utilized. It can be halted at any time and can be utilized. Only the thing is the efficiency depends upon how much time we put on the how many iterations or epochs we put on to build this tree search algorithm. The more epochs we put, the more bigger the tree we build, the more efficient the tree is built, and the more confident we get the optimal solutions. So the first step is to utilize this equations one to identify which node to be selected, and this has two terms: the first node and the first term. The first term is the value it is given to that particular node, and second term is something like how many rollout has been done total, and those with that total number of rollouts, how many times these nodes has been visited, nj. So this is like a kind of an exploitation, and this is kind of an explorations, like random exploration. So this is the CP is a term between a kind of a trade-off between exploitation and the explorations. So once the best value based on the UCB is selected, and it expanded by doing a forward model dynamical system in here in car racing for one time steps. Once that is been done, then it has a random player. So we have some random acceleration, braking, and steering. Then we do how many samples are possible, we make an expansions. Once the expansions is done, and we try to reach to select a particular one which has a good since we don't have a terminal state, because it's normally done is which has a good terminal state is been taken forward, but since we don't have a terminal state, there will be a heuristic functions will be applied to back propagate and to identify which node has a highest value for that particular rollouts. So it's an anytime, as I can mention, it can be stopped and can be utilized for the car racing. So again, we said that it has a limitation that we cannot go for any random sampling any large amount. It has this car racing has nearly for each tick has only nearly about 20 milliseconds. So based on that thing that we have to make best uh, we have to follow these four steps within that particular time frame. Sorry, not this one. When we are doing a forward model, this forward model has to, after this training, this forward model has to obey this time tick. So what we have to do is we have to based on this adaptability, what the strategy they followed in here is they are the say this is a t time step, they do a one forward model and try to come to the next state. So they have these two states, the initial state and the final state. To reach the optimally the final state, they utilize this MCTS search algorithms for different evaluations. And once that different evaluations are done, then based on that the best decision thing is taken, and it has been applied, and it kept moving forward. So as mentioned earlier, to train this one, we need it's a sampling based algorithm. So to get those different random samples, we need a forward model, and to give some critics to the each samples, an evaluation function is being utilized. So this simulation, this is related to the, this is a fundamental concept of MCTS, but related to the talks, we don't have the forward model requires a track model in an Euclidean space, but what we have is only the sensor data that hasn't been explained here properly. That's what they try to give is they don't give the track model like kind of a global path like a set of waypoints. What they do at every instant, they will give you some kind of a sensory informations. For each ray there will be like kind of a bunch of rays from minus 180 degree to plus 180 degree, and every say in for every interval of 5 degree. So how much and how much long the ray travels will give you an indication that that is the promising direction that the car has to move. So only this sensory information, based on this sensory information, that has to be converted into Euclidean domain to identify where your track is on the particular track instant. Then the forward simulation has to be applied in a different samplings. Then that each samples forward simulations on how which samples has gone out of the track, which sample has given a promising directions. Based on the evaluation function will decide that. Once that is been done, then we will be transforming back to the sensor data, and that particular accelerations and steering will be applied, and that the training strategy will keep on going. But one among the drawback here, the MCTS is, as mentioned earlier, it gives you a value only in discretized space. So, but it is hugely because if we the more number of possibility, it will be enormously exponential possibilities will happen. So, what they do is it is impossible to go into an a continuous action space. So, the discretization of the acceleration, braking, and steering somehow to be done very intuitively. So what they do, they describe the acceleration braking in terms of point 2 from minus 1 to plus 1. Minus is braking and positive is for the pedaling, and the steering is from 0 to 1 or minus 1 to plus 1 in terms of point 1. So minus 1 is for the right hand side, plus 1 is for the left steering. So the evaluation function is based on the equation. So it is nothing but that how much distance it can maximally travel for that particular accelerations and particular initial velocities. So if this, in case if this value is gone beyond a certain limit, then it means that it gone beyond certain values. It means that it has gone out of the track, and that will be penalized by using this second equations. So once these evaluation functions are being utilized, and we try to build a Monte Carlo tree search algorithm based on the equation 1 and equation 2, and once that MCTS is been built and it was utilized with other or algorithms based on human heuristics, logically built based on genetic algorithm, all those things on three different tracks. One is tarmac, another is hill dirty track, another is a hill track. So what author observed is along the tarmac it could be able to compete with all the things, and it could came up with a very high score. But when we coming to the dirty track or off track, which it wasn't built for, because it and the forward model is only built for the, because we used a forward model which was based on the tarmac, so it lacks some kind of acceleration deacceleration while climbing the hill and coming down. So that the poll results came, and it was not that adaptability to the track which it was not supposedly trained. So that was the discussion they made. And uh, and it what they claimed is for what track it has been trained for, it could able to beat all other human heuristic things, and it could able to compete, and it can come uh, uh, it came the highest score in the track what it has been. But compared to the one which is hasn't been, it couldn't able to cope up with the other players. So this is the conclusion they give. So what they did is they tried to because the car racing is a kind of a good platform to apply for different AI methods. And one of the AI method which hasn't been tried so far in the car racing is MCTS. The author had taken a nice effort to build an MCTS controller for car racing, and they trained especially for a car Max, and it performed well on that. But although they tried to put on the dirt and thing, it didn't perform as much. But they could able to identify the reason why it didn't perform, because that forward model for the dirt and hill track is a bit different compared to the tarmac model. So this has given what the author conclusion says is the MCTS based approach may have a big options for controlling a racing cars at a very competitive speeds. Thank you.